Hello, get ready to submerge yourself with Team Anteater. For our MAE 152 final, we decided to analyze an RC car powered by a single piston engine. We decided to focus primarily on the chassis, engine mount, and its moving components. In this animation, you see some of the parts that we analyzed. For example, the piston, connecting rod, crankshaft, and connecting pin are all shown. First off, we have the crankshaft. We calculated that the max force the engine could deliver is 38.6 newtons. The shaft is oriented at 90, 45, and 0 degrees to simulate a turning shaft. With this applied force, a stress between 63 and 69 megapascals is observed. This is below the yield stress, and due to cycling, it will never fail. The piston joint on the left and the connecting rod on the right resulted in a max stress below the 620 yield stress. Even with a 400% increase in applied force, the resulting force was 10 to 40 times less than the yield stress. An excess load of 100 Newton was applied to the engine mount. This resulted in a max stress 60% less than the yield stress and a first buckling factor of 3.04. Due to the revolutions of the engine, it could produce a 466 Hz. The first natural frequency of the mount is an unlikely 3770 Hz. Thermal studies were conducted for the engine. If 270 degrees Celsius is reached, then the car must be shut down immediately. The engine could produce a max thermal power of 652 watts and a convection coefficient of 135 when it is run at max speed. When operated at max capacity, the car overheats in 1.7 minutes and overheats in 2.75 minutes when operated at 95%. To fix the overheating issue, more surface area was added to the engine block for convection cooling. The top 3 fins of the engine block were increased because the combustion chamber is close to the top and this region needs the most cooling. As a result, a more distributed cooling was observed and a temperature of 270 was not reached until the convection coefficient was reached. A 195-pound force was applied to the center of the chassis to simulate a human adult stepping on the car. This resulted in a max stress above the yield stress. To fix this issue, the thickness was increased by 0.01 inches so that the chassis will not yield. To simulate the car impacting a wall, a 450 load was applied to the front of the chassis. This resulted with a first buckling safety factor of 1.9. The car chassis was safe from buckling and yielding due to impact. It was determined that buckling occurs before yielding for this chassis. A frequency analysis for the chassis and for the engine block were also conducted. Please refer back to a report to view the results. Thank you for your time and have a wonderful day.